Welcome. In this session, we're going to talk about how you can protect your business from data leaks that can result from insecure application programming interfaces. This is a very common threat, actually, because we see that they recognize that even industry analysts like Gartner are predicting API attacks to become the most frequent attack vector. This is how our loosely coupled application microservices are predominantly communicating over these channels, and as such, it's very wide open for abuse. Correspondingly, we see data that proves that we see massive increases, even quarter by quarter increases in the number of data attacks based on API exploits. And then we see that it's very prevalent. It's not just targeting one or two instances. We're going to look at a case study example, but by no means are we isolating them and saying, oh, okay, this is very unusual. It's actually very typical. We see that nearly 92% of organizations have experienced some sort of security incident. So let's take a look at a case study example. And again, we're not picking here on Peloton, which just because it happened to be in the news and it's been reported on. What went wrong? And how can we protect ourselves from something similar going wrong in our own organizations? Peloton, at the time of this attack, a health company, it makes these bicycles that you can connect, stationary bikes you can ride and have fitness classes even in remote environments. They had 3 million subscribers at the time. And they had multiple security flaws in their application programming interfaces. For example, anyone with just generic internet access, you didn't even have to be a Peloton member. You could go into Peloton's website and get information about any one of their members, your user IDs, their location, their age, their gender, even their weight. If perhaps I'm an unscrupulous individual and I want to try and get some sort of personal information about someone I've seen at the gym, I could get all that, their age, their weight, even whether they're in the studio or not. It's very creepy. But this information was exposed even though the Peloton user may have designated it to be private. Well, what went wrong? Well, to better understand that, let's take half a step back and say what needs to go right in order for these API-based communications to work. Let's use an example of a reservation. We have a user named Bob. He wants to make a dinner reservation. He logs into a site, and he might enter information about when and where, the time, but he would also enter information relating to the payment to hold that reservation. You might want to then share this information with his date, Alice. And Alice should be able to access some of that information, but not necessarily all of it. She'd want to know where and when the reservation was to be held, but not necessarily. Bob may not want to share his payment information with Alice on their first date. So some of that information should be kept private, and some should be able to be shared, provided the proper user has logged in with whom that wants to be shared with, like Bob wants to share with Alice in this case. Okay, so what can happen though if things go wrong? Well, the first thing is you could have people that have no credentials and logging in and just combing and trolling for data and might find out about that information. They're not authenticated, they're not challenged, and just go through the database until they find some of that information. This is called Broken User Authentication, or BUA. Additionally, you could have users who may not be allowed to have that specific information, like this specific record. Maybe Angela's ex-boyfriend is stalking her and she wants to know, Alice's ex-boyfriend, is stalking her and wants to know where and when this dinner is going to be held. And so he's trying to find that out. He shouldn't be allowed to do that. He's not party to this. This is called Broken Object Level Authentication. He doesn't, in this case, Seamus does not have the proper authorization for this reservation record object. Then finally, we could have one more type of break, and this is called a Broken Function-Level Organization. Maybe Bob's ex-girlfriend, Angela, she just wants to mess with it and delete this reservation entirely. That's a function that she shouldn't be allowed to do because she doesn't have the proper authorization for it. So this is Broken Function-Level Authorization. Okay, so then let's go back to our overall use case and see what went wrong. Well, we see in this case there was broken authentication. This is one of the OWASP top 10 for APIs. The OWASP stands for Open Web App Securities Project, and they've identified this as one of their top 10 security concerns, and they recommend always having proper authentication in place. It seems pretty intuitive and obvious, but it is that prevalent that it's been explicitly called out. It's number 2 of their top 10. Then, additionally, there was Broken Object Level Authentication. Users were able to pull up records that they shouldn't have had access to. They're not being shared. They're not, maybe you might have a group of friends that you want to share your workouts and details and when you're in the gym, but this wasn't restricted in any such way. It was open to all. Then finally, there was clearly a case of excessive data exposure. This is also an OWASP top 10 for API security. So then, this leads us to how can you protect yourself from these type of exploits? We're going to take a look at Cisco Panoptica, Cisco Application Cloud Security. It's also another name for the product. Let's take a quick look at a demo of how we can use this tool to protect ourselves from these types of threats. Okay, so here we are in Panoptica, Cisco Cloud Application Security. Instead of the dashboard, we're now going to dive into API security, and from there we can see that we can get information about the security of our internal APIs, the subset of those which are externally exposed, third-party APIs that we may be connecting to, as well as in our CI/CD pipelines, various API calls there. So let's take a look at, first of all, internal APIs. We can see the overall security posture of all the internal APIs that we're developing. We can click on them to get more information, and for instance, you can see here that we can get findings all the way down to the lines of code. So very similar to what we were discussing, a missing security scheme is the first and the most critical finding that came to the top of the list. We see that, okay, it's highly recommended for API operations to have a security scheme. There's neither a global nor an operation-specific one in these cases. And then we're seeing all the different instances right down to the lines of code where this is pointed out, and we can get all that information back to our developers and thus harden our APIs that are being internally developed. Not only this, that we can also take a look at third-party APIs that we're connecting to. So these ones we're not developing them, so we don't have insights to the lines of code, but we could take a look at their overall security posture. For example, here's one of the top findings I'm seeing in this particular API. They're using actually a deprecated version of transport layer security. And why this, and we're going to see all the instances where this has been flagged, and why this is of concern is that because it's a deprecated version, it's susceptible to man-in-the-middle attacks, so people could actually intercept information that we're sending over these APIs, which of course is a huge concern, to be able to eavesdrop over those conversations. Then finally, we can even look in our CI/CD pipeline and see exactly what are the status of various API calls there. For instance, here our spec analysis engine has again defined and identified, for instance, missing security schemes for authentication, same type of issues that we've already seen in our case study as well as in some of the internal APIs. But what's really important here is that we're finding it in the pipeline, and therefore we're correcting the problem at the root. So very quick and easy way that we can increase the security of all our APIs in our organization, whether these are internal, externally exposed, as well as third-party APIs and even APIs in our CI/CD pipeline. There you have it. Very quick, very easy. We see multiple ways we can protect ourselves from API exploits that could be used to leak sensitive data, as we were discussing. How can you start using and get going with Panoptica? Just go to panoptica.app. You can start using it for free. You can click and you can see demos and videos and papers and case studies, everything relating to it. But most importantly, what I think is great is that you can just start using it. So single cluster, 15 nodes, no feature limit, no time limit. Get out, test drive, see how it can bring value quickly to you and your business in protecting yourselves from, among other threats, application programming interface leaks. Thank you.